sum and difference of cubes. We did squares yesterday. We had to have squares for it to work, and it was difference of squares, so we had to have a minus for it to work. This one is sum and difference, so for this one it could be plus or minus. It doesn't matter, okay? Doesn't matter if it's plus or minus, but it has to be cubes. Do you know any cubes? I'll give you one. 8. Because 2 times 2 times 2 is 8. 2 cubed is 8. So you kind of have to know the cubes. 1 is a cube because 1 cubed is 8. Is 1. 27. Very good. 3 cubed is 27. 64 is 4 cubed. 125 is 5 cubed. Not sure we'd go much further than that. 1,000 would be 10 cubed. So you kind of have to have it in your head that those numbers are perfect cubes, okay, and what their cube root is. So the formula is not painted on the wall, so you're going to have to know it, although there is a trick painted on the wall to help you with it, okay? So the first thing you do, there's 2 parentheses. The first one, you take the cube root of each term, and you write the same exact sign that is in the problem. So if it's a cubed plus b cubed, in the first parentheses you'd write a plus b. If it was a cubed minus b cubed, you would write a minus b. That's why I wrote the plus minus exactly the same way. It would just follow. There's another parentheses, and it's larger. It's going to have 3 terms in it. Okay? Here's what you write. It's all going to come from the first parentheses. The first term, you square the first term. The last term, you square the last term. And in the middle, you do one of each. A times B. So the beginning is double the beginning. The end is not double, but square the beginning. The end is square the end. And the middle is a little bit of each. A times B. As for the signs, after the A squared, you do the opposite sign of the problem. So I've written it as minus plus to let you know that it's the opposite sign. And then at the end, between the AB and the B squared, it's always plus. On the wall, the trick that I have, or the help that I've given you, is this little doohickey right here to help you remember that the beginning is of the second term is you square the first term, the end you square the last term, and the middle you do one of each, which is basically, this thing, this little picture painted on the wall. Square this, put it here, square this, put it here, take one of each, put it in the middle. Okay? So let me show you one. Y cubed minus 8. They are both cubes. A variable with an exponent is a cube if the exponent is a multiple of 3. So y cubed is a cube, y to the 6th is a cube, y to the 27th is a cube because it is a multiple of 3. Y to the 45th, multiples of 3, those are cubes. And the cube root is whatever it is divided by 3. So the cube root of y to the 3rd is y. Same sign. And the cube root of 8 is 2. So you take the cube root of each one with the same sign. That's the first parentheses. Somewhat similar to difference of 2 squares where we took the square root, only this time we're taking the cube root. For the larger parentheses, to get the first term, you square the first term. So y squared. To get the last term, you square the last term, 4. To get the middle term, you take one of each of those and multiply them together. 2 times y, 2y. Ignoring the sign on the 2. You just take the actual 2 and multiply it by y.
Does it matter if you do y too?
Write 2y. As for the signs, the first sign is going to be the opposite of what you wrote in the first term. So we wrote y minus 2. So our first sign is going to be plus. And then our last sign between the 2y and the 4 is always plus. That is how you factor a y to the third minus 8 using the difference of cubes. We're not really simplifying it. I think you would agree that we're not making it simpler. We're making it factored. We're making it into 2 different factors. We're making a factor tree for y cubed minus 8. Okay. Let's try again. N to the 6th plus 27. Those are both cubes because the exponent is a multiple of 3 and 27 is a cube because it's 3 cubed. First thing we do is take the cube root of each term. What is the cube root of n to the 6th? N to the second. You divide the power by 3. Just like yesterday when we did square roots, we divided the exponent by 2. So the cube root of n to the 6th is n squared. Same sign as the problem. And the cube root of 27 is 3. To get the first term of the second parentheses, we square the first term of the first parentheses. N squared squared is n to the 4th. To get the last term, we square the last term. 3 squared is 9. And then in the middle, we do one of each. 3 times n squared is 3n squared. The first sign is opposite the problem, really. So it's a minus. And the last sign is always plus. And if you took this red mess and you distributed this and combined your like terms like we learned in 6.2, you'd get this as an answer. You would get that. We're not changing what we're dealing with. Okay? We're factoring it. All right, you do that one. All right, here's my answer. X plus 1, x squared minus x plus 1.